Hello again, this is Sample Physics here again, and today I'm making a video for my Year 8 class today. I'm looking at circuits today, and what we have here so far is we've got as you can see, we've got a cell. Okay, so basically this is actually the cell here, and the thing to remember is that the cell actually is shown with a positive, if I can write it properly here, positive, and that's a negative part of the cell here. Now what we have essentially is that the current is actually flowing from a positive to a negative direction. Really, that's quite important, that is. And what we're going to have also, we're going to have two things here. These are called resistors. So resistor 1 and resistor 2 actually in series with the circuit. So what we're saying is that if you've got two components that are going to be actually connected in line with the rest of the circuit like this, we call the resistors actually connected in series. Key word is the resistors are connected in series within this simple circuit. This is an example of a series circuit. Now, in order to actually show you what happens if you combine the values together for the two resistors, we can actually sort of add the values of the resistors together and actually replace these two resistors with one single resistor. And to do that, we're basically going to show you this diagram here, where the combination of both resistors here, if you add the resistors together, we can replace the two resistors just for one resistor, and we call that R total, the total resistance. So that base circuit is exactly the same as that circuit, but all I've done is replace the two resistors for one resistor. So for example, if I show you another circuit here, for example, that's the wrong one actually, so I'm showing you this one here, for example. Now if you've got, let's say for example, a 5 ohm resistor here and a 6 ohm resistor here, and you've got 7 amps flowing through the whole circuit like so, we can actually calculate the voltage V1 and V2 as well. And to do that, we have to use a formula, and the formula basically is V equals to current times by resistance. Whatever happens, don't get bogged down by this formula, because I actually stands for current. That's your current, okay, and then the R is going to be your resistance. Okay, and that's important. No, that's important, that is. And also remember that the current is actually measured in amps, and the resistance is measured in ohms. Okay, so going back to what we just said right now, is that we've got a circuit here right now. We've got two resistors actually in series like this right now, and we've got 5 ohm and we've got 6 ohm in series, and we can actually calculate using this formula, voltage is current times resistance. We can work out V1, and V1 is going to be your 7, which is 7 amps here, multiplied by the 5 ohms will give you 35 volts across this resistor. Okay, so across this resistor we will have 35 volts altogether by calculating it by doing 7 times 5 using the V equals I times R formula. Do a similar sort of thing with this resistor here as well, because bearing in mind the most key important thing, remember, is that the current is always going to be the same flowing through a series circuit. If you've got a loop circuit like so, loop circuit like this, the current at this point, 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 okay, it's going to be exactly the same all the way through, 7 amps all the way through. Hence, that's the reason why when we do voltage is current times resistance, the current is still going to be 7 amps times by the resistor 6 ohms will give you 42 volts altogether. This is all for sample physics here right now, and basically what I'll do is I'll make another video just to basically push things on forward. Thanks, bye.